when we see an inequality like x is less than or equal to -5, hopefully we know what to do with it. It's a closed dot that gets shaded to the left, or it's an inequality from -infinity to 5, an interval from -infinity to 5. But we may not have seen ones like this before. X plus 1 is less than or equal to 5. Now, the nice thing is, with inequalities like this, we can still solve it for x the way we would if this was an equal sign. We just have to be a little bit careful about it. On this one, I'm going to get rid of that plus 1 by subtracting 1 from both sides. X is less than or equal to 4. And I'm done. It is true, right, that 4 plus 1 would be less than or equal to 5, and same with 3 and 2 and 1. So that's here relatively simple. We will see as we go on the one way in which solving inequalities is different from solving equations. If we have 3 times x is less than or equal to 18, we're going to get rid of that times 3 by dividing by 3 on both sides. And we've got 6 and x, and we can keep our inequality sign the same. X is less than or equal to 6. If we've got x divided by 5 is greater than 4, to get rid of divided by 5, I need my inverse operation. I'm going to multiply by 5 on both sides, and x is greater than 20. Now, here's the one way in which these are different from regular equations. You'll notice all this time I've been drawing the line and solving just like I normally do for equations. There's one very important difference. When here I have negative x, which we can remember that's a little -1. X is an invisible little 1 there. So if I'm trying to get this to be just x, plain old positive x, and I divide by that -1 on both sides, whenever I am dividing or multiplying by a negative number, I have to do a very important thing and flip my inequality sign so that x is less than switches and x is now greater than the answer to that problem. So the -1's cancel. 4 divided by -1 is -4. And here's my new equation. X is greater than -4. Here's why we have to flip the inequality symbol. If you think about this problem, -2 is less than 3. We can see that that's true. -2 is definitely smaller than 3. If we divide by -1 on both sides without changing the inequality, we can now see we have 2 is smaller than -3. That is definitely not true. 2 is bigger than -3. If we flip the inequality, as we know we must when we are dividing by a negative, we have a true statement again. 2 is greater than -3. Remember that when you're switching the sign of something, you're doing like the opposite of it, right? So if x was bigger than 10, then its opposite, -x, is going to have to be smaller than -10, right? Here, maybe x was 12, and 12 is bigger than 10. Excellent. But when we have -10, -12 is smaller than -10. Think about that number line again, right? Here's 10 and 12, and down here is -10 and -12. So when we have our opposite answer, we change the sign, we have to have the opposite inequality symbol. It flips. Every time you multiply or divide by a negative, you must flip the sign, the inequality sign. Okay? So here we go solving. We're going to divide by -3 on both sides to get x all by itself. But danger, danger. We are dividing by a negative, which means we must flip the sign. Everything else proceeds as normal. These cancel. We divide. We're done. But we made sure to flip x's greater than or equal to negative 12. And you can see, if you put in negative 13, whether this would work or not. Negative 13 being smaller than negative 12, right? Or if you put in negative 11, which would make this true, would that work for this equation? All right, we have x divided by negative 2. To get rid of that divided by negative 2, I'm going to multiply by negative 2 on both sides of my equation. These guys cancel. Danger, danger, alert, alert. We multiplied by a negative. We must flip the sign every time. But we're done. X is smaller than negative 20. All right. We've got a more complicated problem, but the steps don't get harder. We just still have to get x all by itself. So I'm going to get rid of this minus 2 by adding 2 to both sides. Do I need to flip the inequality? No. All I did was add. Nothing to worry about. 4 times x is less than 28. We're going to divide by 4. Do I need to flip the inequality? No. We divided by a negative. And we're done. All right. Ooh, look at this mess. All right. I want to get rid of this plus 7. I'm going to minus 7 on both sides. Do I need to flip the inequality? No. I just subtracted. It doesn't matter that it's negative because I was not multiplying or dividing by it. I was just subtracting. Now from here, you could divide by 3/5 on both sides. I prefer to do this in 2 steps, so I'm going to get rid of that divide by 5 by multiplying by 5 on both sides. Sorry, this was just an option. Don't want us to get confused. I'm not currently doing that. These 5s cancel. 12 times 5 is 60. And now I'm going to divide by 3. Do I have to flip the sign? No, because 3 was positive. If at this stage you had just done 12 divided by 3/5, you would also get 20. I am dividing by 3/5. I'm just doing it in 2 steps. Oh, would you look at this mess? All right, we've got x's on both sides of the equation. So my first step is going to be to get x's on the same side. Your first step could be to subtract 10 or subtract 15 or to add 20x instead of adding 15. All of those are great steps. I just picked this one today. All right, still trying to get x all by itself. I'm going to move this 15 by subtracting 15 from both sides. Oh, this is interesting. Negative 5 times x is greater than negative 5. I need to get x all by itself, so I'm going to divide by negative 5. Alert, alert, alert. Boop. We have to flip the sign because we divided by a negative. So those cancel. I've got just x over here. Negative 5 divided by negative 5 is 1. And in this one, x had to be smaller than 1 to make this true. Oh, my. All right. I would like to do away with this fraction. I have this divide by negative 3. Let's times by negative 3 on both sides of the equation. Alert, alert. Oop, that's a positive 21. Whoops, negative times a negative is a positive. When I multiply by a negative, I absolutely must flip the sign. I hope you just said that out loud with me from wherever you are. These guys canceled. So nice. I just have 3x plus 9 left. That's a positive 21. Negative times a negative. Okay. All right, let's subtract 9 on both sides. Do I have to flip the sign? No. It's just subtracting. Don't need to worry about it unless I'm multiplying or dividing. All right, 3 times x is greater than 12. Divide by 3. Do I have to flip the sign? No, because I'm dividing by a positive number. So don't have to flip it when I'm dividing by a positive. Ooh, look at that. X is greater than 4. Fantastic. So simple.